Hi, I'm Gretchen. Yes, I work for PG&E. We all know what that is because we're all in San Francisco, right? Sometimes I tell them, people are like, what is that? I'm not going to talk too much about the work we do at PG&E. I'll show a couple of examples. Before I was at PG&E, I was working actually on a surgical robot, which is sort of what made me interested in this topic because it was a robot. And it made me think about automating things, and it made me think about the ways in which we decide to automate things and whether we make good or bad decisions when we do it. And I really appreciated that first introduction as sort of a primer to ethics, because I'm not going to talk about that. And I also think it's interesting we're talking about artificial intelligence, because I appreciated last night Roger's point that we don't really have artificial intelligence. What we have is some fancy math. We have algorithms. We have some data, we have some big data, we have some machine learning. So I'm just going to talk about smart things so that I don't have to disambiguate between those different levels of things. What I mean is, the more and more things are responding contextually to a situation, to changing rule sets, to their inputs, to who's using them, to their place, the design of those things gets harder. I've been doing this for a long time, and those of you, we have our wireframes and our journey maps, and we kind of used to think about these like monolithic experiences, and like we are the creators of these things. And that doesn't happen when you design smart things. You have to be able to respond. You're in more of a dialogue with the person that's using this. And so it made me realize my practice needs to change, and all of our practices need to change. I'm not going to teach you all about that tonight, but I'm going to hopefully give you a few kind of tactical things and kind of conundrums that you're likely to face as you design smarter and smarter things. And then, this is an open thing. If you have ideas, I'd love to hear them, because I think we're all going to be struggling with this in the coming days. And, I missed a slide there. There's a great book by a guy named Nick Bostrom called Superintelligence. And superintelligence is when the machines become as smart, if not smarter, than human beings. And there are people who say with 50% confidence we think that's going to happen in like 2040, and those in the know say with 80, 90% confidence that's going to happen in like 2080, 2090. Well, when the machines are super intelligent, it's actually not so hard. It's when the machines are like not quite so super intelligent that we need designers, right? We are the interface designers. We are the brokers of the people to the systems. And so what happens when the intelligence fails or it's hard to understand, we have to come up with ways to make that work for people. So, I don't know. Did I really sign up for this? Oh, I'm looking at the wrong slide. Why? No wonder this is not making sense. I had this reaction at first, sort of like, is this really my job? Do I have to learn some math? I also appreciated Roger's point last night of like, you don't actually have to know the math. The tools are pretty good. But you do have to have a really good sensibility for what people want and for what they're going to respond to and for what context they're in. All those tools we already have. You just have to learn how to do things in a slightly different way from those kind of monolithic tools that you've had before. And it starts off with asking, is this thing even good? So when I was designing the surgical robot, I would be watching our prototypes in the OR on a cadaver or an animal, and I would watch problems, and I would think, oh, I'm going to design a solution around that. And I would bring it to the engineers, and they'd say, oh, don't worry about that. We're going to automate that. And I would think half of the time, does the doctor want that automated? And the other half of the time, I would think, but what if you can't? Or what if you automate it poorly, right? So why are we really automating this thing? So the first ethical dilemma is this thing good? I am a hater of bathroom automation. I understand it is supposed to keep the germs away. I'm not a germaphobe. I can operate the goddamn handle much more reliably than trying to game the system. And in the book Superintelligence by Nick Bostrom, he has some great examples of when machines get smarter, they do it in unusual ways. So he has the example of if you had an AI that was supposed to make paper clips, when it's at its natural conclusion, what it's going to do is consume all of the resources of the universe to just make all of the paper clips, because that's what you told it to do. There's actually an AI that was created to see if it could tell the difference between different types of Asian people from photographs. And it did eventually learn to do this, not based on physiology, not based on eyebrows or eye size or shape. It cued off of haircuts, collars, clothing, like cultural cues, right? And so machines learn in ways different than we expect that they're going to learn. They're going to get to the outcome we want them to get to, but they're going to do it in unexpected ways. And so as designers, we probably want to be involved with how are those things learning? And I'm going to talk a little bit about ways we can do that. And as I was designing the robot, I have young children, and I was in the car one day because I was commuting a long time, and I thought, what if I had a robot nanny? What would happen? Now, I have 2 kids. If my sister hits her brother, the robot is going to have to use the attachment parenting chastising method or the authoritarian parent method. And I thought, well, am I going to have like a Russian nanny pack or a like Buddhist Tibetan nanny pack? Do I have to train it? None of that sounds appealing. And then what happens if she hits the robot? Because that's what's going to happen, really. And Asimov's laws, right? So a robot, somebody's going to have to help me out here. The robot can't hurt people. It has to listen to people. And it can protect itself as long as it doesn't violate the first 2 rules. So I'm thinking, like, what's the robot going to do when she hits it? And then I realized, like, the whole point is I want her to stop hitting things. How is the robot going to be useful in this situation? And this is actually starting to, like, drive me nuts. I'm not sure I want it. And then there's this awesome guy on Twitter, speaking of people who I know and love on Twitter but don't actually know or love. Dan Hahn has been writing awesome microfiction, and this was his provocation about what happens when a virus attacks your autonomous car. He's actually got a great newsletter of his short fiction. You can get really dystopian about this stuff. You can get really Black Mirror about it, and I promise I won't do that to you tonight. But as you start thinking about these cases, there are these kind of fun edge cases, and we all know software developers, they will go to those edges. And as designers, we're always trying to think about the main case. And I think with smart things, it becomes harder to just focus on these, again, monolithic happy paths. You start to have to think about those edge cases, because to the point earlier, they start to have real ramifications in the way of like, well, if one person doesn't complete their purchase on Amazon, what the what? But as you're starting to be discriminatory as a purpose using intelligence, it's going to matter. So what's the big deal? As stated earlier, these things are not neutral. Algorithms inherit the biases of the people that make them. One of my favorite stories from last year is a Japanese cucumber farmer decided to use TensorFlow to sort his cucumbers. Now, this is not like a computer programmer by day who also is a cucumber farmer. He's a cucumber farmer, and he successfully created a system that could sort cucumbers at least as well as his grandmother, which is awesome. I'm all for being judgmental about cucumbers. It's got a place. Not so much when we're talking about things like beauty. So there was a bunch of people on, I think it was 2 newscasters on Good Morning America. Good Morning America. Science has figured out the perfect shape and size of the human nostril for perfect beauty. Science. Does anybody know who the owner of the perfect nostrils are? That's right, Kate Middleton. She has the perfect nostrils. Meanwhile, there are 2 African-American newscasters sitting on either side of these people just like, fucking nostrils? Really? Like, nobody stopped to ask, like, nostrils? Come on. That's like 101 level bias. So, this is a faked up image, but as you're creating an algorithm and you're doing machine learning, you have a funnel of training data. And the wider your funnel is, that's going to determine where you get to as an output. So something that we as designers can actually do is say, what's going into this funnel? And you could take a look and say, I'm noticing something about this funnel, and it's got a certain color range to it, and it's got a certain cheekbone situation going on, and it's got a certain nostril thing going on, and maybe we ought to widen our funnel. So there's something known as a local maximum, which is it's the best optimization within this locality, given this input system. But if you widen that or shift that input one direction or another, you're going to get a different output. And so we as designers, even though if you don't know all the fancy math, one of the things you can do is say, what's going in the top? Tell me how you started. And there's a great book by this woman, Cathy O'Neill, Weapons of Math Destruction, and she math destruction, and she describes them as things that are easily scaled, so you can replicate them, you can deploy them, and they have deep and harmful effects. Fantastic book. And she makes the point about test scores. So those of you who have children in public school, I used to work in education. The No Child Behind Act created standardized testing. And the point of that testing was to say, if we're going to give dollars to schools, we should have some measure of whether they are good schools or not. Very simple. So those kids are taking those tests. It's actually not to judge your kid. It's the idea of that is to judge the school. So, okay, that sounds all right. But these things are getting used to actually judge teachers now. So teachers are being fired or moved based on whether or not their students are performing well in this test. Okay, so somebody asked Kathy, could you please go look into the math here and tell me, I've lost my job, I want to know what happened, because I think I'm a good teacher. For years and years, I've been a good teacher. What happened? So she went and she asked, and they said, well, we can't tell you the math. If we told you the math, it's intellectual property. If we told you the math, people would game the system. So we've all heard about, in Atlanta, there was a huge cheating scandal, right? There's been these huge cheating scandals. People are gaming the system, and they're gaming the system by teachers literally taking the test for their kids so that they look good, because they might lose their jobs. We have taken something that was meant to serve the people and made it to penalize teachers. So she does makes this awesome point, which is if your algorithm is good, people should game it. If you're using good inputs and good math, people should game it. And she uses a FICO credit score as a counterpoint. So one of the key components of your credit score is, and I swear this is not because I work at PG&E, but whether or not you pay your electrical bill reliably. Because that's a hard thing to actually game. And by the way, what a wonderful thing to game. Like, you're a steady bill payer, right? That means you're consistently predictable, you have a decent income, and you're covering your core needs. You're keeping your lights on. So a weapon of math destruction is bad, but a good algorithm can be gamed, and that might be a good thing to do. You'll have good proxy measures. Now, another thing to look for in these algorithms as a designer, and again, you don't have to get into the math, is how stable are the results? So when you look at test scores, and I've seen this in several different locations, a teacher will be bad one year, then they're great the next year, then they're in the middle quartile the next year, and then they're back up to the top, and then they're back down to the bottom. So if your results are not stable year over year, if you're not seeing a consistent output, that is a good indicator that you don't have good math. So that is another question as designers that we can say, which is, how stable is the input? How reliable are our results? How predictable are those results? And before we go firing teachers, how many times did they move around quartiles? Right? Those are some basic questions that we can bring to the table. So I want to show you a simple example from PG&E, and this is not a particularly ethical one, because this is talking about the algorithms that we use to think about, of our 2.4 million polls in California, which ones should we replace this year? And we do this because we don't want a poll to fail. If a poll fails, a couple things might happen. It might take out a neighborhood. It might cause a wildfire. It might fall in an environmentally sensitive spotted owl nest. So we have a couple of key things we look at, which is, what's the health of this asset? What's the health of this poll? How likely is it, do we think, to fail? And if it did fail, how critical is it? So that's a very simple model, and everybody in this room knows a 2x2. You can think to yourself, all right, I'm following. But then we did something that I thought was really interesting. The data scientists allowed us to have a design workshop to talk about, well, how could we create this model together? So I've Greeked all this data. It's not actually that accurate, but it's representative of what we did, which is to say, okay, what historically do we know causes the failure of this asset? And down the side here, well, okay, we have the conductors, the wires break, the pole breaks, the cross arms break, a tree hits it. And then our number one issue is trees, right? Trees fall in a storm. We have drought years followed by El Nino years. That causes us all kinds of problems. So that was interesting, because the very next thing that happened in a workshop that had designers, it had people from the business, it had computer data scientists, it had software developers, we started to have a conversation about, like, well, wait a minute, like, company initiated, what does that mean? We cause our own things to fail? Let's dig into that. Like, let's ask ourselves what each of these, and let us interrogate this. And again, we didn't have to get into the math, but we could start to have a meaningful conversation on equal footing of like, is this the right data? Now, again, this is not a particularly like ethically oriented example, but if we go back to the like, what's the perfect nostril size or eyebrow arch or whatever your algorithm you're gonna use for Tinder or whatnot, you can have a conversation, you can have a workshop that says, what are the right inputs? What are the right points to make these decisions on before you got it put into Python scripting? So, given that these smart things are not neutral, we can help people see their biases by kind of pointing out, hey, your funnel is perhaps not wide enough, or it's mislocated, shifted a little to the left. We can help people look for those unstable results. How much are things moving around? And can we build this together? Before you go put it into a black box, and Roger last night had kind of a great example of like you would take some stuff, put it in a black box, and out comes the other side. Well, hey, as designers, you want to have some basic understanding of that black box, and one way to do that is to co-create it. Now, for sure, you get into super complicated algorithms, and even the data scientists will tell you they're not entirely sure what's happening in the black box. But even walking up to that, you should have some understanding of what that is so that you can help yourself and help your users. So the second pitfall is about security and privacy. I think Andy was saying she wanted to have security and privacy have a big part of this, and no designers cared about security and privacy? Really? I wonder how many more of them would care about that than ethics, because it's a new deal. It's a big deal, and it's a new area, and there are new infection vectors. And I'll mean that quite literally, as I'll show you. I recently, I'm not a big Venmoer, but I started using Venmo, and I realized that my best friend, who does not live her life out loud on the internet like I do, had her entire payment history visible to the world. I texted her, and I said, oh my God, and she said, oh my God, and she changed that setting. And I went there yesterday to get this screenshot. It's still up there. So first of all, what was the design meeting where somebody decided social tab? Second of all, who said that should be the default setting set to public? And third of all, who said you can't go back and turn off your activity in the past? So this is kind of basic 101, I'm assuming. I'm seeing some nodding heads. Like, this is stuff that, like, for the love of God, let's stop that. If anybody works at Venmo, I'm looking at you. A slightly more sophisticated example, Sonia Kestering at the Interaction Design Conference earlier this year, she works at Collective Health, and 12,000 people a year die from bad data. What that means is 12,000 people a year are declared erroneously dead based on bad data. Now, identity theft is pretty complicated to come back from. Apparently coming back from being declared erroneously dead is like near impossible. And she makes the point that a lot of this could be avoided by, again, this is kind of 101 level stuff, but like before you go roll out the algorithm, run a pilot on your data. Be expecting that your data is imperfect, especially when you're about to make a catastrophic decision like declaring somebody dead. And by doing that, agile development thing, you could mitigate a lot of this risk. In her talk, I'm sure it's online, is actually a fantastic one for those of you who are interested in this stuff tonight, because she's got a lot of really practical things to do, because your output's only as good as your input, and we all live with bad data, I'm assuming, because I always have. And as designers, it can be a little frustrating, because again, we like that monolithic assumption that it's all the happy path and we've got great inputs. And this, you may, again, back to the Star Trek example, you may feel like that's not my problem, but it really is, because your work is going to live or die on the quality of that data. And then just to get slightly more dystopian, anyone who says, I refuse to build the Muslim registry, we already built it. Palantir already built it, it's already in existence, that ship sailed. So we're going to have to get a little more aggressive on the defensive end of this stuff. Colin Meagill runs Polis. Polis is using AI to help governments sort of understand what their constituents feel and think about their various initiatives. And he, kind of makes this point that the work is really done. The work is really to be done in kind of the defense and creating the better mechanisms to support governance, not in declaring I refuse to build Muslim registries. This also extends to everything from like, border guards want your social media password. They've probably already got it. They probably already know all of your situation going on. So I don't know how much you need to worry about that. But and then, who here has heard of CRISPR? Some. So CRISPR is a technology that we use to edit the genome. It's a relatively new breakthrough, and it lets us very specifically say, I'm going to turn this pig with blue eyes into a pig with brown eyes, or a pig with no wings into a pig with wings. Really, we're going to talk about CRISPR. We're not going to just talk about CRISPR, we're going to talk about CRISPR and something called gene drive. So gene drive says if I take this edit to a genome and I tie it to something that is 100% likely to be taken up, I can really predictably alter at scale genomes. Which leads me to think I will be someday carrying around an app on my phone and like accepting and rejecting edits to my genome, right? Like, oh yeah, no, I wanted that one. No, didn't want that. Oh shit, turn that one off, right? We're gonna need some defensive tools here, and we're gonna have to kind of stretch ourselves to get into a place where we're willing to, again, not just be happy path people, but also enable people to defend against things that they never really saw coming. There is some, this is being used to fight Zika. That's great. We should definitely probably edit the genome of mosquitoes so they don't carry Zika. I prefer that to the Bill Gates Foundation, like let's wipe out mosquitoes, because that's possibly catastrophic to our biome. Like that's a huge source of food to a lot of animals. So there's like some good stuff here, and I don't want to, you can't put this genie back in the bottle. So again, my push to you is to think about, and I learned about this at a conference with a lot of kind of biotech people, and they were like, please get designers to go work for the DoD. Please get designers to go work in this stuff, because you're not there, and left to their own devices, these engineers are not going to do this very well, or at all. Again, I promise not to be too dystopian. So on the upside, we all know about PGP. There was a great story, and I believe it was in Glenn Greenwald's book about when he was first meeting Snowden, and he realizes in a conversation with him that they had actually met online something like 18 months before. And Snowden kept saying, I won't talk to you anymore unless you install PGP. And Glenn Greenwald just couldn't get around to it, because have you tried? It's really fucking hard. It's a total like usability nightmare. So Simply Secure is a nonprofit that is trying to help bring design and usability to security. It's a tough nut to crack. The more secure something is, the less usable it is. But, we've done great things, the designers in this industry. I believe we can move the needle on that security usability paradigm. And they have some really wonderful resources. That toolkit that I've mentioned up there is on their website, simplysecure.org. On a more personal level, there are lots of resources out there, and I believe someone tomorrow is even talking a bit about how you can secure your own life. This is a great place for us to get involved and make a real difference. So, as smart things open up these new infection vectors, we can do some things like help people fight for their own anonymity. We can design for bad data and create kind of simple, usable defense mechanisms. And then the third issue and last issue I'll talk about today is sort of this idea of trusted agents. We hear the stories about Alexa in our home ratting on us to the DEA and whatnot. We invited her in, I don't know. And again, as I was working on the robot, I got kind of really into robots. But so people will lie to robots to avoid hurting their feelings is the title of this story. But I think the actual point of this story is they made two robots. The robot would deliver pizza. One robot would just deliver the pizza, and one robot would drop the pizza and then say, I'm sorry. Which one did people like better? The one that said, I'm sorry. Like, we can't help but project our human stuff onto these trusted agents. And again, back to how the computers don't learn like us, we're irrational. We can't help but treat things personally. Some people make the point that Alexa has won over Siri for the very subtle things that, like, her voice inflection is better. Like, she just seems a little more human. She's a little less the thing I noticed about in designing the surgical robot, and so on the lower right here, this is, you can tell from the industrial design, this is not the one I worked on, this is probably 20 years old. Very quickly, people are able to, with augmentation, have this sort of synesthesia that goes on. So I watched doctors who had spent their entire careers and who would tell me to my face that I had this feel, they'd talk about how they had $1 million hands, and I'm sure that is true. But with the robot, their hands could be nano-sized, they could have a lot finer control, they could have a lot more strength, a lot more accuracy, and it really did not take them very long to transfer their kinesthetic knowledge to their eyes. Just like flight simulators or Grand Theft Auto, right? We've all played video games, and that paradigm holds true in reality as well. And so that's a bonus, that these things can unlock new potential, just like it's just as valid to read with your fingers as it is to read with your eyes. I've done work with dyslexics who have a really, really hard time reading, but if you flash one word at a time, if you take away the strain of having to scan lines, they can read as fast as I can, right? So we don't need to be afraid of this stuff if we can kind of, as designers, embrace the fact that these agents can actually help us. That's a real tool, and that is something that the product management types might not know. I mean, I had a lot of arguments with the people at the surgical robot place who just really, they wanted to hold on to that kinesthetic thing and actually give up some of what they were offering as a benefit. And it took like 30 minutes to switch from a lifetime of hands to using your eyes. This is a security robot. Why does it look like a Dalek? Like, this has to be intentional, right? Like, how did this happen? I don't understand. But the point here is, as we make these agents out in the world, they don't have fuzzy front ends currently, right? And so if you get to super intelligence, that's great. You have a kid skateboarding in the parking lot, he's gonna get away with a slap on the wrist, maybe depending on his skin color. Back to maybe the robot is slightly less biased than the humans. But I think about Holocaust survivors I've talked to, and a lot of their stories are by the grace of that one person bending a rule, here am I. So I think as designers, we're gonna have to make these front ends a little fuzzier. We're gonna have to give them some amount of give and take. And we're gonna have to make that argument to our product management types and our finance types to kind of change the game from it isn't just a total optimization all the time. If the goal of this public servant Dalek is to serve the public, to protect and serve the public, then we better think about having it have some flexibility and not just kind of drop a hammer every time. Bill Gates came up with this provocation, maybe the other ethical dilemma we face with these agent technologies is putting people out of work. Maybe they should pay taxes. I actually love this idea. I think it's a pretty provocative one. This is the kind of thing that design thinkers would totally come up with if they put their minds to it. And I think we're the kinds of people who can help with that. What are other ways to mitigate that very real threat to humans? I was at food camp last year when I was really on this topic, and I had a little session, and we kind of did the trolley problem. So, right, what happens if a car can choose between hitting 3 kids or 1 crossing guard, and what if the crossing guard is pregnant with twins? And you could go on and on and on about what if. And this one guy got really frustrated, and he says, look, man, if I hit somebody with my car, at some point you just say, shit happens, bad luck, you didn't intend it, we're gonna agree to let you go here. So what if we could do this for our computers? And he came up with the Act of God plugin. What if you could just have a random number generator that's you get off, you go to jail. You being the car there. This car is liable, this car is not liable. Again, not proposing that we actually put this in autonomous cars, but this is the kind of thing that we're gonna have to come up with, which is how do we make these rules a little more flexible? So, if we have these agents out there being trusted, can we make our robots expressive, help them make us have that synesthesia, have us make that sense transference, and be a little fuzzy in the front end, have a little I don't know, sure, today, bad luck. So, just to recap, We have these algorithms are not neutral. We have opened ourselves up to some infection vectors for security and privacy issues, and we have these trusted agents which maybe don't deserve our trust currently or won't in the future. And there's a lot of stuff that we can do. We can help people see those biases. We can check those funnels, check those results. We can keep our eye out for bad data, and we can kind of work on those agents to make them a little fuzzier. And then just to close, I really liked this. This is a great piece from Mike Lukides. It's part of what makes Black Mirror such a great series is it's what we fear in ourselves. And this, we've always had fear of technology. This has been with us probably since fires, probably some like fire haters back in the day. Like, technology just does what we do with it. And so as the technology gets smarter, it becomes a little harder to see. I think to your point earlier, it becomes a little harder to kind of interrogate what's going on. And so don't abdicate it. Just because it's math, I don't know if you're an I hate math person, but don't get intimidated. Get in there in the conversation and be there for the human beings that you represent as a designer, and know that we all want the same thing in the end, in theory. So how do we make sure, just as we do today, that we're fighting for the user even with the smartness? Really loved this the other day. Your mom told you don't talk to people on the internet and don't get in their cars, and today you literally summon someone from the internet and get in their car. And we love it, right? So I think that I want to leave you with this is not something to be scared of. This is not dystopian. There is a very real challenge, and I think we can work through it, but we need to be brave enough to step up to it. So with that, I'm going to leave this up here. There's some really great things. So I mentioned the Weapons of Math Destruction book by Cathy O'Neill and that Super Intelligent book by Nick Bostrom. There's a great show on Netflix. It's about 40 minutes long or so about sort of the secret life of algorithms, and it's a really good primer. I watched it before I went into that workshop with the data scientist, because I admit I was a little I don't know. Moral Machines is a really readable piece by some New York Times journalists. There's that Simply Secure blog, and then Brian Christian and Tom Griffiths wrote kind of more about how human brains actually use algorithms every day. And again, it's a really good kind of primer for you to have a reference point of oh, this algorithm is going to be like the one that I use when I decide where I go to lunch. So I want to leave you with, this is all doable. We are going to get there. I'm going to throw my Mary Tyler Moore hat. And with that, see if there's any questions.